Developing electrochemical systems is hard because they sit at the intersection of several imperfectly understood areas of physics, and because the markets they serve leave little room for inefficiency. We have learned from working on client projects that commercially viable systems can be built if you follow 3 core principles that will help you make confident decisions on the path from bench to plant. 1. Connect the science to the economics early. Start at the market, then work backwards to define the performance you need to achieve at the electrode. Translate those requirements into the quantities you can measure now: current density at a defined voltage, Faradaic efficiency, or pressure across your flow field. Range the uncertain inputs rather than burying them. A sensitivity analysis will reveal which numbers move the dollars per kilo and which do not. This discipline prevents premature scale-up and helps make choices quantitative. 2. Development is fastest when modeling an experiment is run as a closed loop. A minimal, physics-based model, capturing ohmic contributions, kinetics, and dominant transport effects, forces clarity about assumptions and exposes the largest uncertainties. Then, design experiments to probe those uncertainties directly. As evidence accumulates, lock decisions deliberately. When the repeat unit meets its modeled targets, integrate into larger assemblies soon enough to surface real-world behaviors. But don't be tempted to leap straight to container scale. Large prototypes lengthen iteration times and convert uncertainties into sunk cost. Use them only when they answer questions that a smaller rig cannot. 3. Treat risk as a deliverable alongside current density and efficiency. The most consequential risks typically span physics, manufacturability, and economics. For example, stack replacement drives OPEX, but can be a function of catalyst stability with realistic contaminants and part tolerance stacks that define its compression. Make each risk explicit. Attach a retirement plan that combines model and a discriminating test, and track decisions that follow on from outcomes. Electrochemical systems are buildable when teams connect laboratory measurements to commercial metrics, let models and experiments steer each other, and manage risk with the same discipline you apply to the cell. If you do that well, you gain the ability to make confident decisions on the path from bench to plant.